Welcome back again to this additional tutorial. We are still on the simultaneous equation, and this time this is the question that is set before us. This question says that 3x plus ky equal to 8 is said to be equation 1, and the equation 2 is x minus 2ky equal to 5. And the first part of the question states that with these given two equations, show that or prove that x equals to 3. And the second part says that given that y equals to L, determine the value of k. Anyway, this is not a big deal at all. We'll start the whole analysis by saying solution. Being given the first equation to be 3x plus ky equal 8, and this one is said to be x minus 2ky equal 3. We can solve this equation simultaneously by trying to manipulate either equation 1 or equation 2. There are many ways to do that, but at this time I would like us to consider the equation 2 being this one is x minus 2ky equal 5. Now, if we multiply the second equation by, let's say, you see there are many ways to do it. We can eliminate ky in order to find the value of x, which is another alternative. Or we can also multiply this second equation by -3 and add both equations in order to eliminate the x value. We can also choose to multiply the first equation, this one, by 2 in order to eliminate the ky to find the x. Whichever way we go, I mean, we are not going to have it wrong. But since this is a private tuition, I think we have to go far. We have to stretch ourselves, I mean, to do everything that we have to do just to show you the alternative approaches to solve such kind of equations. For instance, if we prefer to eliminate x by multiplying the second equation by 3, it is not a big deal. We'll multiply it by -3. And watch here, you can see that multiplying the second equation by -3 as we are trying to eliminate the x. So it becomes -3 times. Then we multiply this one also to -3. Then we multiply this one also to -3. So you can see that we call this one equation 1 though, and this one by equation 2 being multiplied to -3. This is it. Being multiplied to -3, being multiplied to -3, being multiplied to -3. Then we say that adding equation 1 and 2, you can see that we have, if we are trying to add equation 1 and 2, we have 3x plus -3x will give us 0. And then, let me watch my screen, whether you can see everything right there. Yes, I think that you can see. And then 3 plus minus 3x plus minus 3x will give us 0x. Then we have ky plus, though this shouldn't be, we should make this one. So let me watch my screen whether you see everything clearly. And the 2ky, that one wasn't so that clear, but I'll try to make it clear so that you can see it properly. This side is minus 2ky. We are trying to multiply to minus 3, as we are multiplying both sides by minus 3. In that case, you see that we have ky. But in the first place, let us try to multiply minus ky to minus 3. Minus ky times minus 3 is equals to plus ky. In that case, plus 6ky plus ky will have 7 plus 7 ky. Why? Minus 3 multiplied to minus ky added to ky as we are adding equation 1 and 2 together. We have plus 6ky. And then at this side we have 8 plus. But in the meantime, we can say that 5 multiplied to negative 3 will give us negative 15. If being added 2 plus 8, we have 7. So you can see that. Is there any space over there that we can continue? Definitely there is one there. So you can see that we have here 7ky equal to 7, which indicates that ky equal to 1. Do you know what? I think I paused the video while I was writing it. I never knew that, the video was paused and I kept writing everything. Now let me go back again to show you what we've done. As we started the whole analysis, I said that we can either use any of the equation to perform elimination approach, to eliminate one variable in order to find the other one. And in this second attempt, I pick up this equation being, I think, where were we? Yeah, I pick up this equation and I said that ky is equals to negative 1. So as we already know the value of k1, then we can put it inside either equation 1 or 2. So if you prefer to put it inside equation 2 over there, you have x minus 2ky. Instead of the ky being minus 1, you put it over there, and then you have equal 5. Then, you try to make the s the subject, as we've done here, you have 3. And alternatively, you could also have used the 3s plus ky equal 2. If you are going to use the 3s plus ky equals to 2, bear also in mind that the ky is negative 1. So we pick up this equation and we try to put ky equal to negative 1, because we have already found it that ky is equals to negative 1. So as we pick up the first equation, then 3x plus ky, we also write plus ky and then put negative there, equal 8. and we try to make the s being the subject, so it became we push the negative one to the right hand side, because being negative at the left hand side, when it crosses over the frontier at the left hand side and come to the other side at the frontier, the sign will change. So being negative over there, when it crosses the frontier, it becomes positive. In that case, we have 3s equals to 8 plus 1. And we make the 3s being the subject equals to 9. And then we divided through by 3, and we had s equal to 3, being the same way. And now, I also use this second approach that been given the two equations. We could also have used the equation 1, and this time by multiplying both sides by positive 2 in order to eliminate the term ky being one of the variable. In the previous one, we used minus 3 to eliminate x being one of the variable, and at this time we prefer to eliminate y in order to find x, which is also possible. So we pick up the first equation, being 3s plus ky equal to 8, and we multiply it to negative. We multiply it to positive 2. Why did we do that? Because we saw that this one being negative 2, if we multiply the first equation by positive 2 and we try to add them, it would automatically, eliminate ky. That's why we choose positive 2 to multiply to the first equation. And this is what we did over there. So if you see this side, you see that we have here the same equation there. We have multiplied both sides by positive 2, and we have got this one over there. Now, and I said that let us try to do equation 1 minus equation 2. This time, this is same as the equation 1, and this is the same as equation 2. So if equation 1 minus equation, we are going to do subtraction, then equation 1 minus equation 2 to be equation 1. We had 3x to multiply to 2, we have 6x. Then plus, this one will be adding equation 1. Adding equation 1 to 2, because if we add equation 1 to equation 2, we will automatically eliminate the ky. So we have equation 1, 3s multiplied to 2 give us 6s. Then being added to x, we have x over there. Then equation 2, equation 1, 2ky minus ky, we had it over there. And we had 2 times 8 plus 5. We had 16 plus 5. But we can see that plus 2ky has cancelled the negative 2ky. So we were left up with 6x plus 7 equals 16 plus 5. 6x plus x equals 7x. 6x plus x equals 7x, and 16 plus 5 is equal to 21. So we have 7x equal to 21. And then we divided both sides by 7. So we have 21 over 7 equals to 3. Exactly the same as what we try to have in this at these points. Now, having known the value of ky, in that case, the equation, the whole simultaneous equation changes. So, in our next analysis, honestly, as far as the question is concerned, precisely, we have seen that, we have solved the question outright. If we like, we can end here. But remember, this is a private tuition. That is why anything private must be excellent. Must be done excellently. I cannot leave the solution up to this point. We can do further analysis. As we are doing that, we enhance our mathematical capability, and we maximize our strength in mathematical algebra. This is it. So I would like us to take the analysis further. This is it. So at this time, I would like you to do me a favor by just copying everything as you see there systematically. Everything has been done systematically. Copy everything, and then we will do more with the same equation. So pause the video, and then we'll come back to put that value ky over there, the value minus 1 over there. We are going to put it there, and then we will try to solve the equation. Now we come back. Before we move on, we shouldn't forget that we've been told that y equals to half. In that case, we can pick up this equation or that equation while we know that s equals to 3. So probably let us try to pick up equation 2. From equation 2, we are considering the b part. From equation 2, x minus 2ky equal 5. Then we have x minus 5 equal 2ky. Then we have x minus 5 equal 2k. What is y? We are told that y is equals to half. So this one will cancel this one. Then we have x minus 5 equal k, where x we already know to be 3. In that case, is there any space over there? In that case, we have 3 minus 5 equal k, which implies that k is equal to minus 2. We could have used the same equation to find that k is equals to minus 2. Now, let's see. Oh, having found, you see, the previous one, we had, I think we had k1. Or, using the relation, the previous relation rather, qy equal minus half. And we know that where y has been provided, to be y equals to half, then this equation becomes k times half equal to minus half. Minus half cancels half. So we have over there 1. Oh, maybe I did it too fast, because to some people it may not be reasonable to STEM students. So let us make it simpler. We know that, well, so therefore we will say that k equal 1 over y multiplied to minus half. K equal, what is 1 over y? Already we know that y equals to half. Therefore 1 over y, 1 over y will be 1 over half. 1 over half is the same as 2. So we have 2 times minus 1 over 2. This 2 cancels this 2, so you are left up with k equals to minus 1. Exactly. We are left up with k equal to, wait a bit. I think they were a little bit earlier we had ky equal to minus 1 rather. Earlier we had q1 equals to minus 1. So, and we are provided with y equals to half. So we have k, instead of ky, we say k equals to minus 1 over y. Good. But we know that half is equals to, y is equals to half. Therefore, it's equals to minus 1 over half, which is not different from minus 2. Therefore, k equals to minus 2. Yeah. Exactly as we had here. So whichever way we go by, I mean, we can still have the same answer. And also, the same value, I mean, we could have used the same equation to find k is equal to minus 2. To do that, I mean, we will have to put s equals to 3 in this equation. And then we have to put y equals to half in this equation. By doing that, I mean, you can find the value of k to be also equals to minus 2, which you can try it yourself. Now, let us try to, I think we have the value of k. So our next attempt is trying to put the k inside this equation. And I mean, to extend the analysis further, just as I said previously, I mean, as you came to this point, I mean, you have almost solved every question that the examiner was asking for. But as I've already explained, that this is a private tuition, and we can stretch ourselves further just to enhance our mathematical capability. This is it. Good. Take your time to copy everything, and then we will try to put these values, the value of k inside the simultaneous equation. Take your time. Okay, now, let's say we have the first equation. Now, as we've already found the value of, of k. Now, as k equal to minus 2 in both equations, we have 3x plus ky. We know that k is minus 2, so it will be minus 2y equal 8. This is the proper equation 1. And this one is x minus 2. Ky is minus 2, so it will be plus 4. And then this one is 5. This is the proper equation 2. Now, if you do the simultaneous equation, as we've already done, I mean, you come by with the same, the s equals to 3, and then the y equals to half, as we said. let's try to do it again at this time, and you can see that it is like that. If you try to multiply both sides by -3, just as we did before, and this one is this one should be -3 as well, and this one should be -3. And you try to add equation 1 and 2, you have 3x plus -3x, it will be 0. And then you have -2y plus -12, you have 14y. This is 4y rather, sorry. This is 4y. So -2y plus 4y multiplied to 3, you have minus 14y equal to 8 plus -15, you have -7. Yeah, you can see it on the board. Now, we are left up with, from here, we have y equal -7 over 14. We have y equal -2. Sorry, y equal -half, rather, sorry. Y equal -half. Exactly what we were given. Now, we can also find the x value, which you already know that x is equals to 3. But if you want to find the x value, really, you can put this equation we are using this one. So using this equation where y equal to -half, if you are going to put the y inside this equation, let's pick up this equation. 3x minus 2y. Y is equals -half equal 8. You have 3x plus 1 we pick up from this equation. This should be positive. So 3x plus 2 multiplied to -half will be -1 equal 8, which implies 3x equal 8 plus 1, x equal 9 over 3, x equal 3, exactly as what we found. Now, you can also use the y to y approach to find the same thing. The y value to find the y the x and the y values where both lines will intercept. Now, take it this way. This is the original simultaneous equation. Take your time, copy it. I'll wipe this section again, and we'll try to sketch the graph if possible. Now, we know that the result of the simultaneous equation is 3x minus 2y equal 8. And then x plus 4y equal 5. This is equation 1, and this is equation 2. Whose solution? There are two lines. This is a line, and this is a line. Whose solution is known to be S equals to 3 and Y equal half. So the coordinates of the point of intersection between the two lines, 3x minus 2y plus 8, and the second line, x plus 4y equals to 5, they both meet at where s equals to 3 and y equals to half. Now let's see what we can do. If you pick up this equation, we are trying to, or before we sketch, why can't we use another approach to find the x and y values of this simultaneous equation? Though we know that we will come up with s equals to 3 and y equals to half, we will come up with it. But this is anyway something that is to broaden our mind. So let us use the matrices approach. The matrices approach, assuming we don't know the solution, which we know now that the solution of this simultaneous equation is s equals to 3 and y equals to half. Assuming we don't know, and we are applying the matrices approach. The matrices approach will tell you that if you have these two equations like this, 3x minus 2y equal 8, and this one is x plus 4y equal 5, both equation 1 and equation 2. This one will represent a matrix M, like 3 over there, minus 2, which is that, and x, which is 1x, and 4y, which is 4. Be multiplied to x over y equal to 8 and 5. In fact, this equation 1 and 2, as you see above, it represents the metric, its matrix form is this one. So let me call this one equation. Let me call this one equation sigma. In this equation, this term from here to here, we call it the matrix M. And this term, we call it a big X, very big one. And this term, we call it C. So you can see that we have the matrices of the form M, X equal C. Mathematically, we can prove later on that X is equal the inverse of M being multiplied to C. This equation is very vital, very, very vital. We'll use it later on. I'll call it equation phi. Now, take your time to copy this this portion, and then I think we can carry out from here. Take your time, copy it. Yeah. Now, this is X, big X, and this is inverse of M, and this is C. Systematically, let us begin with the inverse of M. Inverse of M, by definition, is given by 1 over the determinant of M multiplied to the adjoint of M, where the matrix M we know 3 minus 2, not necessarily 3 minus 2, but the minus indicates that there's a minus sign in front of the 2 there. And then 1 over there, and there's also minus 4 over there. This is the matrix M. If you want the determinant of the matrix M, by definition, determinant of a matrix, by definition, determinant, okay, I would say that by definition, if you have a matrix M equal A, B, C, D, then the determinant of M is equals to A multiplied to D minus B multiplied to C. That is the definition, which indicates that this determinant will be M 3 times minus 4 will give us 3 times minus 4, then minus 2 multiplied to 1. We have minus 12 plus minus 12 plus 2. Let me check it, and that is correct. Take your time, copy it, because we will need this side as well. Take your time to copy it. Yeah, we come back. I think there was a slight mistake over there. You see, this is 3 and this is 1. This is minus 2 and this is plus 4. So this is not minus. Very good. And this one is not minus either. And this one is not minus either. So this one is 3 plus. So what we have over there, yep. So we have 14 over there. So we say that the determinant of M, we denote it by this. This is also determinant of M. So the determinant of M is 3 multiplied to 4 plus 2 is equals to 14. Very good. Then if we have the determinant equals to 14, then we note it. Maybe we will clean that side, but I think there is enough space over here to continue our work. So this is the determinant. Now, what about the adjoint of the matrix M? Remember that we still have the matrix M to be 3 minus 2 over there, 1 and 4 over there. The adjoint of a matrix, by definition, adjutant matrix, if you have any matrix like in the form of, if you have any matrix in the form of, let's say, I'll say for a given matrix, M A, B, C, D. The adjoint of that matrix will be adjoint of M will be we will swap the positions of this one. So the D will come here and the A will go there. So we have D, A. But as we have swapped the positions of the relative position of A and D, we will negate B and C. We will negate B and C. So this one becomes negative B. Sorry, this one becomes negative C, negative B. The positions of B and C do not change, but their signs change. This one, the positions of A and D, they do change, they swap, and their signs remain the same. But this one, the positions of B and C, they don't change, but we negate both of them. So now we can see that the adjoint of a matrix, when it is given in this form, this will be the adjoint of the matrix. Now, if you look here and you want to find the adjoint of the matrix, you can see that for this reason, you can see that M, can you see the board? Yeah, M over there, that the 3 and 4 will swap. So you have 4 here and you have 3 over there. And then you will negate minus 2. And then you negate 1. Can you see the board? No, you couldn't. So in that case, I think I will have to clean this session. So take your time. You can't see it, so let me wipe this little bit off. And then we are going to continue at the other session. So at this time, take your time to copy this one, and then we'll pick it up from here. Now, let us pick it from here. In that brevity, we say that the adjoint of M, where M is this one, then it is going to be, we are swapping the 3 and 4. So we become 4 over there, and we become 3 over there. But we will negate this one and this one. But this one is already negative over there. So if we negate it, it will be positive, and then we negate that one. So this is the adjoint of the matrix M, adjoint M. Good. Now, based upon the previous definition, we said that the inverse of the matrix M is equals to 1 over the determinant of the matrix M multiplied to the adjoint matrix M. So we have the inverse of the matrix M is equals to 1 over the determinant is 1 over the determinant M. The determinant M is 14. So 1 over 14 multiplied to the adjoint of M. This is the adjoint of M. So it is 4, 2, minus 1, and 3. Very good. Now, I'll call this one equation nabla. Very good. Remember that previously we said that X equal the inverse of M be multiplied to C. Don't forget that. Be multiplied to C. Very good. Maybe you will call it equation tau. Now, we are going to substitute the inverse m into this side. But before we do that, take your time to copy up to this point. And I'm going to wipe this session so we can continue from this session. We can continue from this point at the other side. Take your time and copy everything as I'm standing by the board for you to have a clear view of the board. Now, we are continuing. From equation tau, we have x, but remember, previously we said that the big X is no different from x and y from the previous equation. And then the m is what we find it on equation, the m inverse is what we find it in the equation nabla. So the m inverse is the equation nabla. So we write equation nabla over there. 1 over 14 4 2 minus 1 3, and then you've been multiplied to c. C, by the way, as we said previously, is equals to c1 and c2, where the c1 and c2 were represented by, let's see the other side of the equation. Yeah, 8 and 5. This equation, we know it already from the previous side of the previous parts of the question. So what you are trying to do is to multiply this one to this one, and then divide the results by 1 over 14, or to multiply the result by 1 over 14. So this one is no different from 1 over 14. Now we have 4, this one 2, it will multiply by 8, 5, and this one will be minus 1, 3, multiplied 8, 5 as well. Okay, so we have 1 over 14, 4 times 8, 4 times 8 plus 2 times 5, 2 times 5. Then we are done with this one. Then we come here. Minus 1 times 8. Minus 1 times 8. Plus 3 times 5. So we have 1 over 14, which is this one. Then 4 times 8 is 32. Plus 10. Then we have 1 times 8, which is 8, plus minus 8. Minus 1 times 8 is minus 8, plus 15. Good. So we have, is there any space over there? We have from here, we have 32 plus 10 over 14. Okay, then let us stretch ourselves. Let us go straight over there and continue from there. So take your time to copy everything, and then as I'm cleaning this board, you'll take your time to copy everything up to this point, and you'll pause the video, and then we'll continue from this point. Now, we are here with x, y equal 1 over 14. It becomes 32 plus 10 is 42 over 14. Then you have here minus 8 plus 15 is 7 over 14. So you have x, y equal 42 over 14 is 3. Sorry. There should be minus of, no, it's correct. Yeah. 42 over 14 is 3, and 7 over 14 is half, which indicates that x is equals to 3, while y is equals to 4, is equals to half. Y is equals to half. This is the solution of the simultaneous equation that we solved previously by using simple strategy. This strategy is the matrices approach, and as I've already said that to solve such a simple simultaneous equation by this way of solution, I call it trying to crack a mere nut by the use by using sledgehammer. I mean, it is disproportionate. But though in the universities, I mean, there are some variables, or there are some strange variables which you may have to use this approach because the variables may be some strange variables, and then if you use this equation, it will be very, very helpful. Because I remember many years ago when I was in the university as a mechanical engineer, I remember on a particular question on mechanics of materials. In those days, the department I was doing the mechanics of materials with, it was in German we call it finite element method. And probably maybe in English you call it finite element method. And I mean, we can, there was a particular question that the figures were, the variables were so strange. In that variables, you could find the modulus of elasticity, which we call it in German, Elasticität-Modul. And you find some other terms, they were so strange. So the only way you can, I believe, if when it comes to that one, the only thing that you can do is to use this approach, or by quoting the Cramer's rule, the rule that we did in our previous session of the tutorial, the Cramer's rule. Anyway, this one that we are doing is still based upon the Cramer's rule. Yeah, if you use this approach, you have it right. As I've said, for some strange variables, you may have to use this approach. But for simple simultaneous equations, as we have already considered, yeah, you may have to use the simpler approach. This is it. Now, if that is the case, then I think you may have to copy everything, and then I'll come with the final word for the day. Now, I will try to stand here for you to have a clear board, so that nothing can conceal your vision. Now take your time, copy everything, and I'll come up with a final word later on. This is x, This is why. The same. Now, I think before I conclude, if you try to sketch the curve, as we have already explained, how to sketch the graph of simultaneous equation. You are very much aware of that. So I don't think that we are going to take all that much of our time to sketch the curve again, and again. But on this particular question, sorry, it is not curve, it is lines. If you are going to sketch the lines, I mean the two lines, I mean, and see where they do intersect. It is something that we have done. We have done previously in our previous tutorial. So it is something that you are very much aware of. So if you are going to sketch the two lines anyway will be like this, something like this. One should be a positive gradient, and the other should be a negative gradient. And this should be the point of intersection where we have s equals to 3 and y equals to half. That's the solution. Yeah. So take your time and then copy everything. Now I conclude by saying that, I mean, this is not a big deal. Honestly, the solution to such analysis, I mean, is so straightforward. And you need wisdom to do this analysis. And wisdom is something that, I mean, it is God who gives wisdom, as the book of James says now, the James in the Bible. As in the book of James, chapter 1, verse 5, it says that if any of you lack wisdom, let him ask of God, that giveth to all men liberally, and he does not upbraid, and it shall be given to that person who asks for wisdom. Don't let anyone to talk you down. You are a child of God. Never let anyone talk you down. And possibly I can tell you, I mean, from my own personal experience, I can tell you that, I mean, you were created in the image of God, meaning you can do everything. You're a child of God. You can do everything. Don't let anybody to talk you down that you can do. I mean, mathematics. I mean, get over it. It isn't something that is difficult. I mean, you can play around with it. There is nothing that you cannot do because you're a child of God. Yeah, God created, He created you in His own image. That is something that you have to be thankful to God about. This is it. Now, thank you so much for your time, and thank you to millions of people around the world, I mean, who are taking or partaking the advantage of this tutorial. Now, we'll bless you, as the Bible says that the Lord said to Moses to tell Aaron and the priest that this is how you should bless the children of Israel. This is how you should bless my children. The Lord Almighty God bless you. The Lord Almighty God keep you. The Lord Almighty God makes His face shine upon you and lift up His countenance upon you and give you peace. God bless you. God bless you. Bye.